Have you ever had this brilliant idea for a research project, you're all excited, and then it just kind of fizzles out? Yeah, you're definitely not alone. It happens all the time, and it's usually because the real first step isn't just having an idea. Today, we're going to crack the code on how you take a vague, fuzzy topic and sharpen it into a research question you can actually truly answer. So let me ask you this. Where does great research really begin? We all think it starts with a great idea, right? A flash of inspiration. But what if I told you that's not quite right? The real secret, the actual launch pad for any incredible project, isn't a great idea. It's a great problem. Now, in the world of research, the word problem doesn't mean something's wrong, like a flat tire. Think of it more like an opportunity. It's this clear, specific, pointed statement about a gap in what we collectively know, a puzzle that hasn't been solved yet. It's the engine that's going to drive your entire project forward. Okay, so theory is great, but let's see how this actually works in the real world. We're going to follow a case study and watch as a really broad topic gets focused, refined, and sharpened step by step into a fantastic research problem. You ready? Let's dive in. And here we go. The kind of topic so many of us start with. Alternative fuels in internal combustion engines. It sounds good, right? It's interesting, it's totally relevant, but as a starting line for a research project, this thing has some serious issues. So why is this a dead end? Well, it's just way too big. It's like saying you want to study the ocean. There's no focus. What kind of alternative fuel? Hydrogen? Biofuel? What kind of engine? And what are we even trying to measure? But the biggest flaw, the crucial one, is that it doesn't point to any specific gap in our knowledge. You just can't design an experiment around this. It's a field of interest, sure, but it's not a research plan. Okay, so how do we get from that big, vague cloud of a topic to something with a laser focus? The answer, my friends, is the literature review. I want you to think of this as your detective work. It's the one tool you have to map out everything that's already known, and more importantly, to find what isn't. And let's be clear, a lit review is not just some passive reading. This isn't about kicking back with a stack of papers. No. This is a strategic mission. You're actively mapping the current conversation in your field. This is exactly how you avoid accidentally reinventing the wheel, and it's how you pinpoint those little unexplored territories, those delicious gaps in knowledge where your contribution can make a real impact. As you're doing this detective work, you'll mainly be looking at two kinds of evidence. You've got your primary sources. These are the original eyewitness accounts, the raw data from journal articles and patents. And then you have secondary sources, like review articles, which are amazing because they gather and analyze all that primary research, giving you this incredible bird's eye view of the field. You're going to need both. Okay, let's get back to our case study and see what our detective work has turned up. The lit review starts giving us these critical clues. We find out that using hydrogen fuel is awesome for reducing smoke and CO. Great. But, and it's a big but, it has this nasty side effect. It jacks up NOx emissions. Then we notice something really interesting. Most of the existing studies are using a fixed injection timing, and they're not trying to combine it with this other technique called EGR. And right there, bam, that's it. We found it. That's the knowledge gap. And from that gap in knowledge, a powerful, beautiful research problem is born. Just look at the transformation here. We went from this super vague alternative fuels to this. Reduction of NOx emissions in hydrogen diesel dual fuel CI engines using EGR and injection timing optimization. Wow, every single word in that sentence has a specific job to do. This is what success looks like. It's specific, right? We know the exact fuel, the engine type, the variables we're playing with. It's measurable. We can literally quantify NOx emissions and see if they go up or down. And most importantly, it is 100% gap-driven. It directly attacks that empty space we found in the literature. Now that is something you can build an experiment on. So now that we've seen a great one in action, how can you make sure that your research problem is just as strong? Let's build a quick checklist, a little quality control test that you can run any idea through. First up, is it researchable? Can you actually answer it with data? Asking, is online education good or bad? That's just an opinion question. You can't really prove it one way or another. But if you ask, what is the effect of online classes on exam performance? Now we're talking. That is something you can investigate, you can collect grades, you can measure things, and you can find a scientific answer. Next, is it original? Now look, original doesn't mean you have to invent cold fusion. A study on student stress has been done about 1 million times. But watch what happens when we add some specific layers. We focus on daily smartphone usage, on first-year students in a post-COVID-19 world. All of a sudden, you're looking at something new, a valuable contribution to an old conversation.
This one is absolutely crucial. Is it feasible? A global study on the mental health of every college student on the planet would be amazing, but it's impossible for one person or even one team. A great research problem is one you can actually finish with the time, money, and access you have. Be honest with yourself about the scope.
So, here's your full checklist. Is your problem researchable? Is it original? Is it feasible? Is it relevant to your field? Is it clear and focused? And finally, is it ethical? If you can confidently tick every single one of those boxes, you, my friend, are in great shape. So let's wrap this all up by talking about why this matters so much. I know it can feel like a whole lot of work just to get to the starting line, but I promise you, this foundational step is genuinely the most important part of your entire research journey. This quote just says it all. You can have the best lab, the most brilliant methodology, and perfectly clean data, but if you started with a weak or fuzzy problem, your results won't mean a thing. Your foundation has to be solid rock. Think about it this way. A strong research problem isn't a chore. It's your roadmap to success. It gives your entire project direction. It basically tells you what methodology you have to use. It saves you from wasting months or even years heading down a dead-end street. And ultimately, it's the thing that ensures the work you do actually matters. So, as we finish up, I'll leave you with this thought. You have the tools now. You know how to be a detective, how to hunt for those clues, and how to find the gaps. The entire landscape of human knowledge is just filled with these little unexplored corners waiting for someone to shine a light on them. The only question left is, what knowledge gap will you be the one to fill?